Hello viewers, in this video lecture, today we are going to talk about the module Power Generation Technologies, in which first unit is lecture 1. We are going to learn about energy basics and its classification. So viewers, here are the important topics which will be discussed in this video. Basics of energy and its various forms, the different forms of energy, various forms of energy, energy conversion, grades of energy, thermal energy basis, classification of energy, primary and secondary energy, commercial and non-commercial energy, renewable and non-renewable energy. Now, we will discuss in details. Basics of energy and its various forms. Introduction to energy is ability to do work, and work is transfer of energy from one form to another. In practical terms, energy is what we use to manipulate the world around us, whether by exciting our muscles or by using electricity or by using mechanical devices such as automobiles. Energy comes in different forms: heat, light, mechanical, electrical, chemical and nuclear energy. In physics, energy is the quantitative property that is transferred to a body or to a physical system, recognizable in the performance of work in the form of heat and light. Energy is conserved quantity. The law of conservation of energy states that energy can be converted in form but not created or destroyed. The different forms of energy are: energy can be obtained in number of ways. It may be in the form of chemical energy, in the form of electrical energy, in form of heat, in form of light energy, mechanical energy, nuclear energy. The SI unit of energy is joule or Newton per meter. Various forms of energy. There are two types of energy: stored, that is potential energy, and kinetic energy. For example, food we eat contains chemical energy. Our body stores this energy until we release it when we work or play. Potential energy is a stored energy, the energy of position. For example, gravitational energy. It exists in various forms: stored energy that depends upon the relative position of various parts of a system. A spring has more potential energy when it is compressed or stretched. A steel ball has more potential energy raised above the ground than it has after falling to the earth. Kinetic energy. Kinetic energy is the energy an object has because of its motion. If we want to accelerate an object, then we must apply a force. Applying a force requires us to do work. After work has been done, energy has been transferred to the object and the object will be moving with a new constant speed. Gravitational energy or gravitational potential energy is the potential energy a massive object has in relation to another massive object due to gravity. It is the potential energy associated with the gravitational field, which is released when the object fall towards each other. Gravitational energy is the energy of a place or position. Water in a reservoir behind a hydropower dam is an example of gravitational energy. When the water is released to spin the turbines, it becomes motion energy. Chemical energy is the energy of chemical substance that is released when the substances undergo a chemical reaction and transform into other substances. It is the energy stored in bonds of atoms of molecules. Batteries, biomass, petroleum, natural gas and coal are examples of chemical energy. For example, chemical energy is conserved to thermal energy when people burn wood in a fireplace or burn gasoline in a car's engine. Nuclear energy. Nuclear energy is a form of energy released from the nucleus, the core of atoms made up of protons and neutrons. This source of energy can be produced in two ways. Fission, when the nuclei of atom splits into several parts, or fusion, when the nuclei fuse together. The nucleus of a uranium atom is an example of nuclear energy. Nuclear power is the use of nuclear reactions to produce electricity. Nuclear power can be obtained from nuclear fission, nuclear decay, and nuclear fusion reactions. Presently, most of the electricity from nuclear power is produced by nuclear fission of uranium and plutonium in nuclear power plants. Stored mechanical energy. Stored mechanical energy is energy stored in objects by the application of a force. Compressed springs and stretched rubber bands are examples of stored mechanical energy. Common examples are capacitor, springs, elevated components, rotating flywheels, hydraulic lift substances, air gas, steam, water pressure. Now, we'll come to radiant energy. Radiant energy is the physical energy resulting from electromagnetic radiation, usually observed as it radiates from a source into the surrounding environment. Radiant energy sources include the entire electromagnetic radiation spectrum, including gamma rays, X-rays, radio frequencies, microwaves, light, and heat. Radiant energy is electromagnetic energy that travels in transverse waves. Radiant energy includes visible lights, X-rays, gamma rays, and radio waves. Solar energy is an example of radiant energy. Thermal energy. Thermal energy refers to the energy contained within a system that is responsible for its temperature. Heat is the flow of thermal energy. The term thermal energy is used loosely in various contexts in physics and engineering. It can refer to several different well-defined physical concepts. A whole branch of physics, thermodynamics, deals with how heat is transferred between different systems and how work is done in the process. Thermal energy is the internal energy in the substances, the vibration and movement of atoms, molecules within the substances. Geothermal energy is an example of thermal energy. Motion. In physics, motion is the phenomena in which object changes its position with respect to time. Motion is mathematically described in terms of displacement, distance, velocity, acceleration, speed, and frame of reference to an observer, and measuring the change in position of the body relative to that frame with change in time. The branch of physics describing the motion of objects without reference to its cause is called kinematics, while the branch studying forces and their effects on motion is called dynamics. The movement of objects or substances from one place to another is motion. Wind and hydropower are examples of motion. Sound is a vibration that propagates as an acoustic wave through a transmission medium such as a gas, liquid or solid. In human psychology, sound is reception of such waves and their perception by the brain. Sound is the movement of energy through substances in longitudinal, that is compression or rarefaction waves. Electrical energy. We can define electrical energy as the energy generated by the movement of electrons from one point to another. The movement of charged particles along through a medium constitute current or electricity. Electrical energy is the energy related to forces on electrically charged particles and the movement of those particles. This energy is supplied by a combination of current and electrical potential that is delivered by a circuit. Electrical energy is the movement of electrons. Lightning and electricity are examples of electrical energy. Energy conversion. Energy is defined as the ability to do work. In sense, examples of work include moving something, lifting something, warming something, and lighting something. Energy transformation, also known as energy conversion, is a process of changing energy from one form to another, such as the conversion of nuclear energy into heat energy, the conversion of light energy into heat, thermal energy into work, etc. In physics, energy is a quantity that provides the capacity to perform work or moving or provides heat. The following is an example of the transformation of different types of energy into heat and power. Oil burns to generate heat. Heat boils water. Water turns to steam. Steam pressure turns a turbine. Turbine turns an electric generator. Generator produces electricity. Electricity powers light bulbs. Light bulbs give off light and heat. More the number of conversion stages, lesser the overall energy efficiency. It is difficult to imagine spending an entire day without using energy. We use energy to light our cities and homes, to power machinery in factories, cook our food, play music, and operate our television. Next, we have the concept of grades of energy. High-grade energy, electrical and chemical energy are high-grade energy because the energy is concentrated in a small space. Even a small amount of electrical and chemical energy can do a great amount of work. The molecules or particles that store these forms of energy are highly ordered and compact and thus considered as high-grade energy. High-grade energy like electricity is better used for high-grade applications like melting of metals rather than simply heating of water. Low-grade energy. Heat is a low-grade energy. Heat can still be used to do work, but it rapidly dissipates. The molecules in which this kind of energy is stored, that is air and water molecules, are more randomly distributed than the molecules of carbon in a coal. This disordered state of the molecules and dissipated energy are classified as low-grade energy. Next, we have is thermal energy basics. temperature and pressure. Temperature and pressure are measures of the physical state of a substances. They are closely related to the energy contained in the substances. As a result, measurement of temperature and pressure provide a means of determining energy content. Temperature, it is the degree of hotness or coldness measured on a definite scale. Heat is a form of energy. Temperature is measure of its thermal effects. In other words, temperature is a means of determining sensible heat content of a substance. In Celsius scale, the freezing point of water is 0 degree centigrade and boiling point of water is 100 degree centigrade at atmospheric pressure. Now, you people might have question in your mind, what is pressure? It is the force per unit area applied to outside of a body. When we heat a gas in a confined space, we create more force. A pressure increases. For example, heating the air inside a balloon will cause the balloon to stretch and the pressure increases. Pressure, therefore, is also indicative of stored energy. Steam at high pressure contains much more energy than at low pressure. Heat is a form of energy, a distinct and measurable property of all matter. The quantity of heat depends on the quantity and type of substances involved. Unit of heat. However, nowadays generally joule as a unit of heat energy is used. It is internationally accepted unit. Coming to specific heat. If the same amount of heat energy is supplied to equal quantities of water and milk, their temperature goes up different amounts. This property is called specific heat of a substance and is defined as quantity of heat required to raise temperature of 1 kg of a substance through 1 degree centigrade. The specific heat of water is very high as compared to other common substances. It takes a lot of heat to rise the temperature of water. Also, when water is cooled, it gives out a large quantity of heat. Sensible heat. It is that heat which when added or subtracted results in a change of temperature. Quantity of heat, generally denoted by Q, supplies to a substance to increase its temperature by degree centigrade, and it depends on mass of the substance. M, increase in temperature denoted as delta T, specific heat of the substance denoted by Cp. The quantity of heat is given by Q is equal to mass into specific heat into increase in temperature, that is Q equal to m Cp dt. Now phase change. The change of state from the solid state to a liquid state is called fusion. The fixed temperature at which a solid changes into a liquid is called its melting point. The change of state from a liquid state to a gas is called vaporization. Now coming to the concept of latent heat. What is latent heat? Latent heat is the heat energy absorbed or released during a phase change of a substance without causing a change in its temperature. When a substance changes its state from solid to liquid or liquid to gas, it absorbs heat energy from its surroundings without its temperature increasing. Conversely, when a substance changes its state from gas to liquid, that is condensation, or liquid to solid, that is freezing. It releases heat energy to its surroundings without its temperature decreasing. Now let us learn the concept of latent heat with a small example. When you heat a pot of water on a stove, the water temperature gradually rises. However, once the water reaches its boiling point, 100 degrees centigrade or 212 degree Fahrenheit at a sea level, it doesn't get any hotter even if you continue to apply heat. Instead, the added heat energy is used to convert the liquid water into water vapor, that is steam. This is because the water is undergoing a phase change from a liquid to a solid. There are two main types of latent heat: latent heat of fusion or melting point. Second, latent heat of vaporization. Superheat. The heating of vapor, particularly saturated steam, to a temperature much higher than the boiling point at the existing pressure. This is done in power plants to improve efficiency and to avoid condensation in the turbine. Now, coming to classification of energy. Energy is one of the major inputs for the economic development of any country. In the case of developing countries, the energy sector assumes a critical importance in view of the ever-increasing energy needs requiring huge investment to meet them. Energy can be classified into several types based on the following criteria: primary and secondary energy. Second, commercial and non-commercial energy. Third, renewable and non-renewable energy. Now coming to first, primary and secondary energy. Primary energy. Primary energy sources are those that are either found or stored in nature. Common primary energy sources are coal, oil, natural gas and biomass, such as wood. Other primary energy sources available include nuclear energy from radioactive substances, thermal energy stored in Earth's interior, and potential energy due to Earth's gravity. Primary energy should be used to designate those sources that only involve extraction or capture with or without separation from contiguous material, cleaning or grading before the energy embodied in that sources can be converted into heat or mechanical work. Secondary energy. Secondary energy is all energy obtained from transforming primary energy, that is electricity of thermal origin. Secondary energy should be used to designate all sources of energy that results from transformation of primary sources. The major primary and secondary energy sources are mostly converted in industrial utilities into secondary energy sources. For example, coal, oil or gas converted into steam. Now, the concept of commercial and non-commercial energy. Commercial energy. The energy sources that are available in the market for definite price are known as commercial energy. By far, the most important forms of the commercial energy are electricity, coal and refined petroleum products. Commercial energy forms the basis of industrial, agricultural, transport and commercial development in the modern world. In the industrialized countries, commercial fuels are predominated source not only for economic production but also for many household tasks of general population Example, electricity, lignite, coal, oil, natural gas, etc. Non-commercial energy. The energy sources that are not available in the commercial market for the price are classified as non-commercial energy. Non-commercial energy sources include fuel such as firewood, cattle dung, and agricultural waste, which are traditionally gathered and not bought at a price, used especially in rural households. These are also called traditional fuels. Now, non-commercial energy is often ignored in energy accounting. Example, firewood, agro waste in rural areas, solar energy for water heating, electricity generation for drying grains, fish and fruits, animal power for transport, threshing, lifting water for irrigation, crushing sugarcane, wind energy for lifting water and electricity generation. Now, we have renewable and non-renewable energy. Renewable energy. Renewable energy is the energy obtained from sources that are essentially inexhaustible. Examples of renewable resources include wind power, solar power, geothermal energy, tidal power, and hydroelectric power. The most important feature of renewable energy is that it can be harnessed without the release of harmful pollutants. Renewable energy is the energy from renewable resources that are naturally replenished on a human time scale. Renewable resources include sunlight, wind, the movement of water, and geothermal heat. Although most renewable energy sources are sustainable, some are not. Non-renewable energy. A non-renewable energy resource is also called a finite resource, is a natural resources that can be readily replaced by natural means at a pace quick enough to keep up with consumption. An example is carbon-based fossil fuels. The organic matter with the aid of heat and pressure becomes a fuel such as oil or gas. Earth minerals, metal ores, fossil fuels, for example coal, petroleum and natural gases, and groundwater in certain aquifers are all considered non-renewable resources through individual elements are always conserved, except in nuclear reaction, nuclear decay or atmospheric escape. Non-renewable energy is the conventional fossil fuels such as coal, oil and gas, which are likely to deplete with time. Non-renewable energy resources include coal, natural gas, oil, nuclear energy. Once these resources are used up, they cannot be replaced, which is a major problem for humanity as we are currently dependent on them to supply most of our energy needs. Renewable resources of energy. Energy sources which are continuously and freely produced in the nature are not exhaustible are known as renewable sources of energy. For example, solar energy, biomass and wood energy, geothermal energy, wind energy, tidal energy and ocean energy. But main attention has to be directed to the following sources of renewable, namely solar, geothermal, wind, biomass and hydroelectric. Solar energy is radiant light and heat from the sun that is harnessed using a range of technologies such as solar power to generate electricity, solar thermal energy, including solar water heating and solar architecture, geothermal, Geothermal energy is the thermal energy in the Earth's crust which originates from the formation of planet and from radioactive decay of the materials. The high temperature and pressure in the Earth's interior cause some rock to melt and solid mantle to behave plastically. This results in the parts of mantle convecting upward since it is lighter than the surrounding rock. Temperature at the core mantle boundary can reach over 4000 degrees centigrade, that is 7200 degrees Fahrenheit. Wind. Wind power is the use of wind energy to generate useful work. Historically, wind power was used by sails, windmills and wind pumps, but today it is mostly used to generate electricity. Coming to biomass. Biomass is a matter from recently living but now not dead organisms which is used for bioenergy production. Examples include wood, wood residues, energy crops, agriculture residues and organic waste from industry and household. Wood and wood residues is the largest biomass energy sources today. Hydroelectricity. Hydroelectricity or hydroelectric power is the electricity generated from hydropower, that is water power. Hydropower supplies 1/6 of the world's electricity, almost 4,500 ton watt hour in 2020, which is more than all other renewable resources combined and also more than nuclear power. Non-renewable resources. A non-renewable resources, also called a finite resource, is a natural resources that cannot be readily replaced by natural means at a pace quick enough to keep up with our consumption. An example is carbon-based fossil fuels. The original organic matter, with the aid of heat and pressure, becomes a fuel such as oil or gas. Earth minerals and metal ores, fossil fuels, coal, petroleum, natural gas, and groundwater in certain aquifers are all considered non-renewable resources, though individual elements are always conserved, except in nuclear reactions, nuclear decay, or atmospheric escape. Now, let us know about natural gas. Natural gas is abundant in nature. Now, let us summarize today's video session. Today, you have learned basics of energy, various forms of energy, grades of energy, thermal energy basics, classification of energy, commercial and non-commercial energy, renewable and non-renewable energy. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you.